All right, picking up where we left off, we are dealing with Campbell Company, who has a bond with a 4% interest rate, while the market has bonds of similar risk that offer an interest rate of 5%. Since investors could get a bond like ours on the market at 5% and ours only pays 4%, Campbell Company is going to be willing, and when I say our, I'm talking about us as Campbell Company. Campbell Company is going to be willing to issue this bond at less than face. And the question is, what type of considerations are going to go into how much Campbell Company is going to be willing to issue this bond for? And there's two pieces of it. There is a lump sum involved here. The lump sum that we're dealing with is the amount that Campbell Company is going to have to pay back at the end of the bond's term, which is the face value. So keep in mind when we're dealing with bonds, the person issuing the bond has to pay interest over time, and then at the end of its life, they're going to have to pay back the face of the bond, which is the lump sum. Oop, that's not what I want to call it. So we have a lump sum, which is the face value, that $10,000, and we also have an ordinary annuity. The ordinary annuity are the cash flows for the interest payments. So the interest payments are going to be, keep in mind what has to pass in order for us to record any interest expense, and it's time. So since time has to pass, the payment is at the end of the period, so it is considered, all interest payments are considered ordinary annuities. So for this ordinary annuity, we have to consider the interest payments, which if this bond is a... Let's go ahead and do the full calculation. You remember this, guys. PRT. Principal is $10,000. Our rate is 4%, because keep in mind we're talking about the interest payments, which is going to use the contract rate, also known as the coupon rate here, times time. Our focus is on the amount of every single payment. If this bond pays interest semi-annually, that means that it pays every 6 months. So times 6 months out of 12 months in a year. Let's put that calculation in our calculator. $10,000 face times a 4% rate, 6 months out of the year. That means that this bond is going to have interest payments of $200 per period. So we have two things that we really have to find the present value of. We have to say, what is the present value of the $10,000 that we are going to pay back in 10 years? And then also, what is the present value of the interest payments that we are going to be making to the buyer of our bond? So in this case, let's start with the face value. The face value is going to be using the present value of a dollar table. We want to find out what's the present value of this lump sum for the amount that we're going to pay back in, I keep saying 10 years, I think, but in 5 years, right? So we know the table is present value of a dollar. Let's find our N and our I. Now keep in mind this pays interest semi-annually, so we're going to use that same consideration when we're finding the N and the I for the lump sum portion of this bond. So in this case, our N, if it's semi-annually, that's twice a year. There's 5 years, so we have a total of 10 payments. Now the I that we're going to use, the I is going to be the market rate. Remember, this could be called market rate, effective rate, or interest rate. We want to discount the bond by this 5% to see what is the present value that would yield this type of 5% yield over the life of the bond and result in a $10,000 face payment, right? So in our case, if it is semi-annually, what do we have to do this 5%? We have to divide it by 2, the number of compounds in the year. So in our case, that would make this I 2.5%. So let's pull up our present value of a dollar table. Present value of a dollar, this is 2.5%. 10 periods. So we have our factor. We are going to multiply that by the present value, the future value to find our present value. All right, so a $10,000 payment that's going to be made in 5 years has a present value factor of 78120. That means that the present value of this $10,000 is $7,812. Let's do the same type of consideration for our ordinary annuity now. We want to find the present value of all of these equal $200 payments. So we're going to be using the present value of an ordinary annuity table. We know that the amount of our payment is $200. We know that our N is 10, and we know that our I is 2.5%. So we can get right to taking a look at our table. If I can find it, sorry. Oh, that is not it. All right, so here, ordinary annuity. We want to go to the present value of an ordinary annuity. And we have 2.5%, 10 years. There's our factor. And again, we want to multiply it by our payment. And if we take our $200 payment, we multiply it by 8.75206. We find that the present value of all of those $200 payments, specifically 10 $200 payments, present value is $1,750 and approximately 41 cents. All right, last step. Now that we know the present value of the face is $7,812, and we know that the present value of the interest payments is $1,750.41, we can add those together to find the full present value of the bond. So we find that the present value of this bond is $9,562.41. Keep in mind, when we're talking about that present value, we are talking about the amount of cash that we can receive for issuing this bond. So we're issuing a $10,000 bond. We're receiving $9,562.41 cash. Why? Because our bond only pays 4% interest when they could go to the market and get 5%. Now, if you're comfortable with this, stop here, but if you do want a little bit of a deeper understanding, if we took this $9,562.41 and we put it in a spreadsheet and we calculated the interest at 5% per year for 6 months and then took out $200 and then did it for another 6 months and then took out $200 and then did it for another 6 months and took it out $200. Essentially, if we kind of showed the money coming out of this account over that 5-year period every 6 months, and then at the end take out the full 10,000, you'll notice the balance is zero. That's what we're essentially trying to do here. And if anybody would like me to take this number 7 example and try to make a video to kind of show you this happening, here we kind of worked backwards to find our present value, but we could go the long way just to try to understand this better. Literally, if you put $9,562.41 in an account for the next 5 years, compounded semi-annually at 5% interest, and you took $200 out every 6 months, and then $10,000 out at the end of 5 years, you'd have a balance of zero. That's what these problems are trying to communicate to you, which I think can be a little hard at first, but if you keep practicing these, I want you to do me a favor and come up with the questions that you have, particularly for question 7, since question 7 is going to be something similar to what you might end up seeing in theory 2, and I want you guys to be as prepared as possible. So as you're going through this, I don't want us to just know how to do it. I want us to understand why it works this way. So if you have questions, please reach out to me. Okay. In our next class, we will get started with Chapter 7. I already sent out announcements with specifically what I think you should be focusing on as you're going through Chapter 7, as well as the essay question that I have for you that I'd like for you to write a short essay for before our next class. But if you have questions, you have my cell phone number, you have my email address. Please feel free to let me know if you have any, okay? And until next time, good work, guys.